In today's lesson, we are going to be finding the volume of composite rectangular prisms. We're going to use what we already learned about finding the volume of regular rectangular prisms, and we'll learn what composite is, and we're just going to build on this. So what is a composite rectangular prism? This is a prism that is made up of two or more rectangular prisms put together. So for example, if you see an L-shaped building or you see a house with an attached garage, these are both two examples of rectangular prisms being put together to create a different shape. So a house with an attached garage, as you can see, there are two rectangular prisms, and this is how we would model it. Here is that L-shaped building where you can see that there's two rectangular prisms, like a long one across the back and one on the left side. So another example would be a stepped bookshelf. So as you can see, there are three different compartments to this bookshelf, and it's represented over here. So in this case, this composite figure has three rectangular prisms in it. If you were looking for at a pool that has different depths, so let's say it's a little bit deeper in one end, like maybe 6 or 7 feet, whereas it's only about 3 feet deeper in the other end. This would be an example of two or more rectangular prisms being put together. So how do you find the volume of both figures put together? What we're going to need to do first is split the shape into simple rectangular prisms. Then we're going to find the volume of each part separately, and then we're going to add all of the volumes together. So in this case, remember, we're going to be using our rectangular prism formula, which is length times width times height. Volume equals length times width times height. So here, first step, split the shape into two simple rectangular prisms. And we do this so that we can make it easier for ourselves to find the total volume. So remember that the volume is in a solid shape. How many cubic units can fit inside of this particular figure? And in this case, we're dealing with yards. So how many yards, how many cubes that are 1 yard by 1 yard by 1 yard can fit inside of this particular shape? So first we can split it either across, or we can also split it up and down. So if we were to split it across, it'd be like a smaller rectangular prism is sitting on top of a larger one. And if we were to split it going down, as you can see here, it would be like I have one taller rectangular prism on the left and then a shorter rectangular prism on the right. But either way, I'm still splitting the same rectangular prism, so my volume combined should be the same for both. So let's take a look at how we would separate these two. So we would say this one is A, this one is prism B. You can see how we separate both on in two different ways of separating both. So we're going to first find the volume by splitting them into two separate shapes, and then we find the volume of each part separately, remembering that we look for length times width times height. So I'm going to look at the length, the width, and the height of A. So as you can see my mouse moving here, this is going to be A. So I'm first looking for the length of A. Remember that length is, we want to know how far from the front it's going to go. So that's what we look for when we look for length, like how far back does it go? We know that length is represented usually using a diagonal line, because if we were to just draw this going straight back, it would look like it was part of the height. So when we're looking to see how far back it goes, we know that it's drawn using a slanted line. So this is showing across the top here that it's going back 7 yards. So our length is 7. When we look for the width, we're looking to see how many cubes across it is, and in this case it's going to be 7 across, so that's our width. Then we're going to look for the height, meaning from the bottom of the surface to the top of the surface, how high it is, and in this case we can see that it's 9 yards, so we have 9. So we're going to multiply 7 times 7, which is 49, times 9, which is going to give us 441 yards cubed, or cubic yards. So that means that 441 cubes can fit inside of this first prism here. So now we have to do the second prism, which is this prism here. Okay, and this is B, it's like that shorter one. We look for the length. When we look for the length, we can see that it is, the length of this is going to be the length of the first prism as well. And we could see that it is 7 yards going back, right? So 7 yards going back. Now we're going to look at the width. The width of this prism is going to be shown up here. It doesn't go the full width, so it's not full 11 yards. It's only this 4 yards right here. But if you notice, these 4 yards plus these 7 yards make a total of 11 yards across. But this prism is only 4 yards across, prism B. So now I'm going to look for the height. Okay, I see that the height of prism A was 9 yards. That's the tallest one, but this one's a little bit shorter. So this was going to be 6 yards. So 7 times 4 times 6 is going to give us 168 yards cubed, or cubic yards, meaning 168 cubes can fit inside of the prism B. So now I go to step 3, which is to add those two volumes together. So the volume for A was 441, volume for B 168. When I add those together, it gives me 609 yards cubed would be the total cubic yards that can fit in here. So now we're going to take a look at the other way of splitting the same exact composite figure, but instead of splitting it where we have two different size prisms side by side, I have one prism A is smaller and sitting on top of prism B. So we're going to use the same steps. First, we have it already broken up. Now we're going to, step 2, find the volume of each part separately. So if we're looking at A, we know that we want the length. We want to know how far back does it go. But when I first look at the length, I'm looking at the top, seeing how far back it goes here. I'm also looking on the side of A, and I still don't see any measurements, okay? But that doesn't mean that there aren't measurements that I can use. So if I know that prism A goes the same distance back as prism B goes, as you can see here, I can see that on prism B, there actually is a measurement of the length, which is 7 yards. So I know that if this is 7 yards down here, then this must be 7 yards up going from the back to the front if I look on top. So on the top or on the bottom, from the back to the front, the length is going to be 7 yards. All right, now it's time for me to find the width. So when I'm looking for width, I want to know how far across prism A goes. I noticed that prism A does not have any measurements that are exactly directly showing me the width across. But I do know that the total width of both, or of the larger prism that's below is 11 yards. And I can use that. So if this is 11 yards, and I know that this portion right here is 4 yards, then this must mean that 11, the difference between this 11 and this 4 are going to be the rest of the yards this way. So 11 yards for prism B minus these 4 yards that are missing gives me a difference of 7 yards. So I can tell that the width of prism A is 7 yards by using what I could see the total width of B was and see what was missing. Now it's time for me to find the height of prism A. I could see that prism A's height is 3 yards. So 7 yard length, 7 width, 3 height, 147 yards cubed in total. So now I move on to prism B. Prism B, I'm looking for the length of prism B. I could see very clearly the length here. Okay, how far from front to back? 7 yards. Now I'm looking for the width of prism B. I can see that the full width of prism B is the full 11 yards that are shown here, so that's 11. And then now I'm looking for the height of prism B. Okay, I know that the total height is 9, but part of that is A. I'm looking for just B. I can see here that the height of prism B is 6 yards. So 7 yards times 11 yards times 6 yards gives me 462 yards cubed. And once again, I'm going to move to step 3, and I'm going to take my two different volumes for prism A and prism B, and I'm going to add them together, and it comes to 609 yards cubed. So that means 609 cubic yards can fit, or cubes that are a yard long, high, and wide can fit here. When I take a look, remembering my steps, okay, split the shape, which I did, find the volume of each part separately, which I did, and then add all the volumes together. And as you can see, whether I split it from and have a shape on a prism on the top and on the bottom, or I have a prism on the left and on the right, I'm still going to end up with 609 cubic yards that can fit inside of these shapes. So that's the volume.